Okay, guys, in this video, let's take a look at computations of a double integral. And in this case, this is what we call iterated integral. So we're going to use that technique to compute a double integral. Okay, so the first thing you need to understand is the limits of integration. So the outside limits of integration are the x limits. Okay, so that would be the 0 to 1. That's how x changes. And then the y would be the inside limits, and that would be negative 1 to 3. So the way we compute it is first we concentrate on the inside integral. So this would be this guy right here, and leave the outside without change. So this is going to be 0 to 1. Now, how do we integrate 3? So remember, integrating a constant just results in multiplying it by the variable with respect to which you're integrating. So that is going to be y. So this is going to be 3y. Then, when you're integrating with respect to y, you treat everything else as a number. So x is also a number, just like 3. So this is going to become xy. Now, when you integrate y, that is the same thing as y to the power 1. So we have the power rule for integrals, which increases the power by 1. And so that'll become y squared. And then we divide by the same thing. But dividing by 2 is the same thing as and then multiplying by 7 is the same as multiplying by 7/2. Now, the next thing you do is you draw a vertical slash, and then you put the limits from lower to upper. But it is very important not just write negative 1 to 3, because it's not clear which variable you're going to be substituting for. So you need to understand that because we were integrating with respect to y, this would be y equals negative 1, y equals 3. And then we still have dx. Okay, so now let's start substituting. So for y, we substitute 3 first. So that's going to be 3 times 3 minus, again, x we leave, and then substitute 3 for y, plus 7/2. Now y is going to be 3. 3 squared is 9. Okay, then minus. Okay, so that's very important to remember that when you're subtracting, you have to put parentheses. So here we got 3 times negative 1 minus x times negative 1, and then plus 7/2 times negative 1 squared. Now let's see if we can already fill out some of the blanks here. So for this question over here, this is where we get 3y minus xy plus 7/2 y squared. Okay, now we want to go ahead and simplify what we got into the once we started substituting. So here we got 9 minus 3x plus whatever is 7 times 9 as well, so 63/2. Then minus, now here we have minus and another minus, so that's actually going to be plus 3. Here it looks like we got 2 minuses inside, but there is one outside, so that's a minus x. And negative 1 squared is just 1, so that would be negative 7/2. Never ever move on and start integrating until you completely simplify your answer. So you should never start integrating right now. You have to combine like terms first. And for that, I will just go to my trusty calculator. Let's go to Desmos. So for the constants, we got 9 plus 63/2 plus 3 minus 7/2. Okay, so that's 40. And for the x terms, we got negative 3x and minus x. So that's negative 4x. Okay, so that'll go in here. And let's just check our work. So it looks like we got everything correct. So now we just have to integrate. And this one is a regular integral. So this is just going to be 40x subtract. Now again, this is x to the power 1. So this is going to be 4 divided by 2x squared. Okay, substitute 0, 1. Now the good news here is that when we substitute 0, we just get 0. So this just means substituting 1 and not worrying about whether it's x or y, because now only one variable is left. So this is just going to be 38. Okay, so looks like that's 38. Now there is a theorem called Fubini's theorem that says that it actually doesn't matter in most cases, except of course when you have like weird cases when the function is not continuous, then you have a problem. But here we are not going to have a problem. So we can switch order of integration and we are supposed to get the same answer. Okay, so let's try that. And again, it's very important to make sure that the limits match up, because remember, x is now inside, so this is your x limits right here, and 1 is outside, so that's your y. Okay, so let's start with the inner integral. So let's start with this guy right here and integrate with respect to x first. And the outside integral is still negative 1 to 3. Okay, so 3 integrated with respect to x would be 3x. Now, x is not a number, so that's x to the power 1, which is the same as 1/2 x squared when you integrate. 7y is a number because it does not have x, which means that this is just going to become 7yx. Okay, and then when we draw the vertical slash again, we are going to make sure that you know which variable you're substituting for. So here it's x. Okay, so let's start with it's actually going to be easier to compute this. Okay, so by the way, I can at this point already put the answer. And then we're going to substitute. So it's going to be easy to substitute because 1 is going to be substituted at first, but then when you substitute 0, you just get 0. So that's not going to be a problem. So that's going to be much faster. Oops. So that's a 1. And then plus 7y. Okay, so simplify this expression. So before you do any integration, you must simplify. So 3 minus 1/2, that's the same thing as 6/2 minus 1/2. So that would be 5/2, and then plus 7y. Let's see if that's correct. That is correct. So now we're just going to go ahead and integrate it. And this time it's a regular integral. We do not have to worry about which variable, because that's just one variable left. So that's going to be 5/2 y plus, again, 7/2 y squared. Now here we substitute, and we're definitely going to use a calculator. So let's plug in the top first. So I've got 5/2 multiplied by 3 plus 7/2 multiplied by 3 squared, which is 9. Okay, so that gives me 39. And then I'm going to subtract the value that if I plug in -1 there. So now let's put -1, and let's put -1 for y. So that gives me 1. So 39 minus 1 is 38. Now compare that with my previous answer where I was using a different order of integration, and you can see that both of them gave me exactly the same thing. So that's also 38.